Alright, we are covering section 2.7 and 2.8 notes. I apologize, the air is running, so hopefully you can hear me. I will try to talk loud. Alright, these are the theorems that you should have put in your notes last night, so we'll try to go over them fairly quickly. The linear pair postulate is the first one we're looking at. I'm highlighting because we will use this a lot. Linear pair postulate says that if two angles form a linear pair, then they're supplementary. We have talked about this in class. We mentioned it in our notes, but here we actually have, this is called the linear pair postulate. So if you have a pair of angles and they form a linear pair, such as angle 1 and angle 2, then we would say that angle 1 and angle 2 are supplementary. Now, I want to make a note that before you use this postulate, you must state that the angles are a linear pair by definition. So, before you use your linear pair postulate, you just have to state, I have angle 1 and angle 2 form a linear pair. Why? Definition of a linear pair. If you don't remember what it is, go back and look. Alright, some of these don't have names to them. They're just theorems that you actually have to write out if you use. If two lines intersect to form a linear pair of congruent angles, so you know they're supplementary, and if they're congruent, guess what? They have to be 90 degrees. They have to form right angles. They are perpendicular. So, if you have two angles that form a linear pair, and they're congruent, then you know that angle L and angle M are perpendicular. Again, that's our perpendicular symbol. If two congruent angles form a linear pair, then they're right angles. It's sort of like the opposite of the one that we had, right? If you start off and you know that they are congruent and they form a linear pair, guess what they have to be? Right angles. So, did I skip one? No, there we are. So we've got angle 1 and angle 2. Are going to be right angles. Very similar to the one above. Next one, perpendicular lines intersect to form four right angles. We've actually had this one. If you look back under perpendicular, two lines that intersect to form four right angles, that was our definition. That's what this is here again. I'm not sure why we have it here again, but you have perpendicular lines, you have four right angles. We don't normally put four right angles, you just put one in, but you know that they are all four right angles. Next, if two sides of two adjacent acute angles are perpendicular. So we've got adjacent angles and their two non-adjacent sides are perpendicular. Guess what? They are going to be complementary. So right here, didn't quite go from the middle. Angle 1 and angle 2, they are adjacent. If they are also perpendicular, obviously they will be complementary. So angle 1 and angle 2 are, why didn't I put the 2 up there? There we go. Complementary. Let's see. Angle 1 and angle 2 are complementary. Alright, so now we're getting to another theorem. You notice this was in bold. This one we use a lot. Right angle congruence theorem. It's just that all right angles are congruent. Don't know what a whole lot about that. Angle 1 and angle 2 are right angles. So anytime that you're given two right angles, you can say that angle 1 is congruent to angle 2 because all right angles are congruent. Our reason is a right angle congruence theorem. Vertical angles theorem. Man, it's another one we're going to use a lot. Make sure you know it. Vertical angles are congruent. We've talked about this one in our notes. But here's the actual theorem that says that. Boom. You've got a couple vertical angles here and here. Guess what? They're congruent. If I really wanted to, I could put in these angles are also vertical. They're also congruent. But guess what? Remember here with the linear pair postulate, you had to say that they formed a linear pair before you could use your postulate? Same thing here. You must state that the angles are vertical angles by definition first, before you use that. First. Okay? So remember, linear pair postulate, always state that they are a linear pair before you use your postulate. Always state that you have vertical angles by definition before you use your vertical angles theorem. All right, congruent complement theorem. We don't use that as much. It's in bold. I'm not going to highlight it because it's not as important. Angles that are complementary to the same angle or congruent angles are congruent. So let's say you have angle 1 and angle 2 are complementary. I'm going to abbreviate. You also know that angle 2 and angle 3 are complementary. If angle 1 is congruent to 2, those are complementary, and angle 2 and 3 are complementary. We know that angle 1 is congruent to angle 3. And the next one is the same thing, but it's the congruent supplements theorem. Angles that are supplement to the same angle are congruent, ones are congruent. So, if you have angle 1, it's going to be the same thing, but we're going to change it to supplementary. If angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, then what do you know? Again, you know that angle 1 is congruent to angle 3. Segment addition postulate. I'm highlighting it. We've done this one already. You've got B between A and C, if and only if. What do you call an if and only if statement? Biconditional. That is correct. That's a biconditional statement. We already have these in our notes, so we've used that one a lot. We have talked about the angle addition postulate, but here's the formal angle addition postulate. If P is in the interior of angle RST, then the measure of angle RST is equal to the two smaller angles. So beautiful picture here. We know what this is. It's just like the segment. We have R. Remember, your middle one is your vertex. We've got P anywhere in your center interior of your angle. So now we know that the measure of the whole angle, well, we got it right here. I'm not going to rewrite it. RST is equal to the measure of RSP plus the measure of angle PST. No reason to rewrite that. All right, so those were in your note cards. Now we're actually going to do the fun stuff and start some more proofs. All right, let's start at number 1. We are given angle ABD and angle DBC are complementary. So might as well start off. Let's just go ahead and get that written as are given. Okay, so we've got it started. We want to prove that angle ABC is a right angle. Well, some of you are going to go, well, of course it is. They're complementary. They add up to give you 90. 90 is going to make a right angle. Well, it is, but we've got to put the steps down. So, let's start with what we're given. That's what you always do. If you're given that they're complementary, we have a definition for complementary. What does definition of complementary say? It says the measure of angle ABD and the measure of angle DBC equal 90. So let's write that. Take what you know. This is usually your key to tell you what you're going to do. Remember, when we're adding angles, it's the measures that we add. Measure of angle ABD plus measure of angle DBC is 90. And that is the definition of complementary angles. Okay, we also know right up here the angle addition postulate. we know that if we add this angle plus this angle, we get the whole angle. We're going to need that in here, so let's throw that in. So the measure of angle ABD plus the measure of angle DBC equals the whole angle, the measure of angle ABC. And that is the angle addition postulate. Now, look up ahead and see what we have in both of these proofs. You see how we use that the measure of angle ABD plus the measure of, that is in both of these. If I know that it's equal to 90, I also know that it's equal to the measure of angle ABC. By the transitive property, 90 equals this equals that, so my first can equal the last. So I can say, let's stay with purple. Measure of angle ABC equals 90, and that is our transitive property of equality. We will also sometimes use transitive property of congruence, so make sure you do property of equality. And if the measure of an angle is 90 degrees, what kind of angle is that? It is a right angle. And that is the definition of a right angle. All right, we're done on that one. Not too bad. Let's move over to the next one. Prove if M is the midpoint of segment AB. I'm going to go mark that right away. How do I mark my picture? Boom, boom, put the tick marks in. Then x equals 3. This is going to be an algebraic proof. These are actually much easier. So, start with your given. M is midpoint of a segment AB. Given, is there anything else I'm going to need from the picture, though, that's not right here? See this right here? Sometimes they add information in the picture, and you're going to want to use that in your proof. But to use it in your proof, you have to put it down in here. So I'm going to go ahead and put that I know AM equals 2x plus 5, and MB is equal to 20 minus 3x. That is still part of my given. I just got it from the picture. But it has to be in your statements. It's got to be in the proof. Alrighty, so I've got that in there. If I know that it's a midpoint, boom, here's my key. When you see the word midpoint, you're almost always going to use definition of a midpoint. What's the definition of midpoint say? Segment, if a point's a midpoint, it divides it into two congruent statements. So I need two congruent segments. Segments. Alright, so AM, segment AM is a congruent to segment MB. Got it. Definition of a midpoint. If segments are congruent, they have what? Equal length. So B. That is our definition of congruence. Remember, this is what the definition says, but we need it equal so that we can put numbers in there. Okay, now that we've got that, now I can plug in or substitute what we know. AM is 2x plus 5. MB is 20 minus 3x. All I do is substitute. Substitution property of equality. Make sure you know it's substitution, not subtraction. And then we're just going to do our math stuff. I'm going to bring my, it's a negative 3x, I'm going to add it over. So that's what's going to be my addition property of equality. So I will add 3x. You don't have to write this out. I'm just showing so some of you are, where did you get that? So that's 5x plus 5 equals 20. How do I get rid of the 5? Well, I'm going to actually subtract it over. So that means my next step will be the subtraction. See, I've got the TRST, subtraction property of equality, which will give me 5x equals 15. So last step is x equals 3. What did I do? Division property of equality. Alright, so we made it through those two proofs. So you know, you can stop anytime if I get going too fast, pause and write. but we're going to rock and roll, and we're going to do a couple more, a little bit longer proofs. But if you notice, we've got some statements here. So let's look at number 3. We are given angle MPN is congruent to QPN. So I know these angles are congruent. So look over here. These did not get numbered. That drives me a little crazy. I like having these numbered so you can follow along, because every now and then you get off, or if you don't have the numbers, I can't tell which one goes with which one. So let's always try to keep these numbered. All right, did you notice in the given, all they gave me was this, but see, all my extra information in the picture got put in. So make sure you always add all the information that you're given. Okay, so then we go from the angles are congruent to saying they have equal measure. I am hoping we have harped on this enough that you know that is the definition of congruence. If the angles are congruent, they have equal measure, or you could go either way. Okay, so now that I know they have equal measure, what happened here? Well, look, here's measure of angle PMPN. They took this out. We did what? We substituted. Substitution property of equality. We took that, put it in there. We did the same thing with the measure of angle QPN. And then from here it gets to be easy. We're just doing some more algebra. What did they do here? This time this person subtracted the 2x this way. So that would be subtraction property of equality. We ended with the negative x. And then how did they get a negative 16? Well, they subtracted the 26 over. So we're going to do the subtraction property again. You can do it twice in a row if need be. Now, how did they go from negative x equals a negative 16 to a positive? Okay, there's actually 2 ways you could do this. Some people like to think, well, I'm going to divide by negative 1. Some people multiply by negative 1. You can either do the division. Oh, I missed my V. Thank goodness for whiteout. You can either do the division property of equality, or you can do the multiplication property of equality. Either one. Whichever way you think it through, I can take both of those. So one or the other. And now wait a minute, what happened here? Okay, well go look what we've got. We've got the measure of the angle MPN here, but this is an x equals 26. This has a, oh look, they took the 16 and what? Substituted it back in there. Took the x out, put in the 16. Now, here, a lot of you will want to say, oh, well, to go from here to here, we added. But remember, the addition property is when you do things on both sides of the equation. When you don't do it to both sides of the equation, which you just combine on one side, it's just called simplify. Or I would even, it's combining like terms. Simplify is much shorter. So boom, we're done with that one. We are down to one last proof. We've almost got it there. Now, interesting, this one, we're trying to, given that angle 1 and angle 3 are supplementary, angle 2 and angle 3 are supplementary, so we're trying to prove that 1 and 2 are congruent. That was actually our congruent supplement theorem. Angles that are supplementary to the same angle are congruent. So a theorem can be proven. So we are actually going to prove, what was it called? The congruent supplements theorem. This is the proof of that theorem. So we don't always do that, but I'm just showing you that we can actually prove this theorem. All right, so our statements given, love that one. Always going to get that one right, right? Now, how do we go from angle 1 and angle 3 are supplementary to the measure of angle 1 plus the measure of angle 3 is 180? It's a definition of supplementary. That's why I told you before it's so important to know your definitions. The definition of supplementary angles said that if two angles are supplementary, the sum of their measure is 180. So we've got that. Now here I'm looking and I go, well, here's this part. here is that part. What do they both equal? They both equal the same thing. Measure of angle 1 and angle 3 equals 180, and 180 equals this by the transitive property. Where am I getting the P at? It's actually a Sunday afternoon and I'm tired. Transitive property of equality. This equals 180, 180 equals this, so the first one equals the last one. There's my transitive property. Now, let's see. Here's my 1, here's my 2. What happened? The 3's on both sides disappeared. How do we get rid of them? Subtraction property of equality. We subtracted them from both sides. And now we have the measures of the angles are equal, so now they're congruent. What property says if they have equal measure, they're congruent? Or if they're congruent, they have equal measure? Yes, that is our definition of congruence. Remember, every good definition is biconditional. It goes either way. And that, my friends, is the end of our notes. Hope this helped.